This video goes over lesson 4.1 part 2, tables. In example 1, we're asked to write the following equations in slope-intercept form. From your vocabulary above, you can see that slope-intercept form is y equals mx plus b, where the m is the slope and the b is the y-intercept. When you see the phrase, write the following equations in slope-intercept form, you should automatically think, I need to solve this equation for y. So let's talk about how to do that. On example 1a, we're trying to get y by itself. This is going to be very similar to solving equations when we just have one variable. The only trick is that your answer is going to have a variable in it. So I'm still going to draw in this line through my equal sign like I discussed in the video on solving equations. And I'm looking at what's farthest away from the y. What do I need to undo first? The thing farthest away is that 2x. How do I undo the term 2x? Well, if it's positive on one side of the equal sign, to move it to the other side, I need to subtract it. So I'm going to subtract 2x from both sides. When I do that, it cancels on the left side, and I'm left with just y. Now on the right side, 4 minus 2x, those two things don't really make sense together. They're not like terms, so we can't combine them, so we have to keep them separate. Proper form says to put your x term first, and then your constant, which means the term with no variable. Now I look at it. Y has no coefficient other than 1, which means that y is by itself, and I'm done solving for slope-intercept form. Take a look at B. Once again, let's draw on our line. What's farthest away from the y? Well, it's at negative 3x. How do I undo a negative 3x? I'm going to move that entire term, and since it's negative, I'm going to add it to both sides. The 3x cancels on the left, and I'm left with just 2y. And once again on the right, the 8 and the 3x are not like terms, so I have to keep them separate. I'm going to write the x term first, and then the constant. Now to continue solving for y, I still have to undo that 2. Well, it's 2 times y, which means I'm going to undo that 2 using division. Notice I divided every single piece by 2. That's the same as if I had done this. I just think it's simpler to do it piece instead of just the entire side. It just makes it easier for me to see. The 2 cancels here, and the last thing that we have to do, because now y is by itself, we still have to simplify these fractions. So we look at 3 over 2, which cannot be simplified, so we leave it as 3 over 2x. And 8 over 2 can be simplified. 8 divided by 2 is 4. Now y is by itself, and this is in slope-intercept form. Practice this again on example C. Draw on my river. The thing farthest away from the y is the 7x. How do I undo a positive 7x? I'm going to subtract it. That cancels and I'm left with 4y. The 14 and negative 7x are not like terms, so I'm going to put my x part and then my constant part. And then once again, to undo that number in front of y, I have to divide, so I'm going to divide each piece by 4. 4's cancel here, I'm left with just y. Negative 7/4 does not simplify, but 14/4 does. Simplifies to 7/2. So slope-intercept form would look like this. So example 2, we're going to kind of utilize what we learned in example 1, but we're going to switch gears just a tad. Example 2 says we're completing tables. And we're going to use these tables to graph lines. This is usually what I do. I like to pick 5 points, one of which is always 0, because 0 is easy to plug in. I look at the coefficient on x. If y is solved for and the coefficient on x is a whole number or an integer, then I just go 0, 1, 2, and then I put negative 1 and negative 2 on the side. That means I have 2 points to the left of 0 and 2 points to the right. Then we're going to plug each one of those in. I'm going to start with negative 2. 3 times negative 2 minus 2. So negative 6 minus 2 gives me negative 8. Plug in the negative 1. 3 times negative 1 is negative 3, minus 2 is negative 5. Plug in the 0. 3 times 0 is 0, minus 2 is negative 2. And lastly, oh, sorry, not lastly, 3 times 1 minus 2. So 3 minus 2 is 1. Now notice I did this almost entire table, but look what I did on this left hand. See how the x's are each going up by 1? Notice the y's. Plus 3, plus 3, plus 3. Probably use that pattern and infer that this last one's going to be 4. Let's just check it to make sure. Now, since we know this is a line, we know that if the x's are going up by the same increments, the y should be going up by the same increments. So instead of doing every single one of these, from now on, let's look for a pattern. Okay, I treat things a little different when they look like example 2b. I still put my 0 in the middle, but if there is a fraction in front of the x, then I look at the denominator of that fraction. Denominator means bottom. And I use multiples of that number. So imagine yourself counting by 4s. 4, 8, 12, 16. Those are multiples of 4. I'm going to use 4 and 8, and then I always mirror that over to the other side of the table and do the opposites of those. You don't have to use these same numbers for your tables. This is just what I have found over the years to be the easiest way to approach this. Okay, so let's find a couple of these numbers, and then we'll look for a pattern. So 3/4 times negative 8 minus 2. Depending on what calculator you're using, if you don't have a fraction button, you could do 3 divided by 4 times negative 8. The way that we set these up and the numbers that we chose, we should get integer answers here. 3/4 times negative 8 is negative 6. Minus 2 would be negative 8. Plug in negative 4. 3/4 times negative 4 is negative 3. Minus 2 is negative 5. And 0 is an easy one. That's why I always go with it, because anything times 0 is just 0. So we have 0 minus 2, which is negative 2. Now, these are all going up by 4s on the x side. What's happening on the y's? Plus 3, plus 3. That means this is going to be plus 3, plus 3. And we don't have to continue plugging in those numbers. We can use patterns. So let's do that on C. What do you notice is the problem on C? First thing I notice is it's not solved for y. So that's the very first thing we have to do. So off to the side here, I'm going to solve this equation for y. Farthest thing away is 3x, so I need to undo that by subtracting. Cancels. Left with negative 2y. Remember, these aren't like terms. So I'm going to keep them separate. Negative 3x plus 4. And then I'm going to divide every piece by the number in front of y. And simplify. Negative 3 over negative 2 simplifies to positive 3/2. And positive 4 over negative 2 simplifies to negative 2. Okay, so use 0 in the middle. Look at the denominator of the fraction in front of x. And let's use factors of that denominator. So 2, 4, negative 2, negative 4. And then we're going to plug those values in. I'm going to plug it into this one that I just solved. It's going to be way easier to find y that way. So I'm going to start with negative 4. 3/2 times negative 4 is negative 2. Or, I'm sorry, negative 6. Said that wrong. It's going to be negative 8. Plug in the negative 2. 3/2 times negative 2 is negative 3, which gives us negative 5. And lastly, once again, 0 is so easy. 0 minus 2 is just negative 2. We can stop there because these go up by 2s. So these have to go up by the same amount as well. Negative 8 plus 3 is negative 5, plus 3 is negative 2, plus 3 is 1, plus 3 is 4. All right, so there's our tables. That concludes example 2. Let's take a look real quick at example 3. So in example 3, we're supposed to do basically what we just did and then graph using the table that we made. So on example A, it's already solved for y. There's an integer in front of x, which means that I'm going to go to just my 0, 1, 2, negative 1, and negative 2. So 2 times negative 2 plus 5. So we have negative 4 plus 5, which is 1. Plug in my negative 1. 2 times negative 1 is negative 2, plus 5 is 3. And 2 times 0 is 0, plus 5 is 5. Each thing on the x column is going up by 1. We go plus 2, plus 2, plus 2, plus 2. Now we're going to plot these points. So we start at negative 2, 1. It means go left 2, up 1 from the origin. Then negative 1, 3, so left 1, up 3. 0, 5, left 0, up 5. 1, 7, right 1, up 7. And 2, 9, right 2, up 9. A little off the graph. Connect your points. Now in example B, we have to do things a little bit different because it's not already solved for y. So the very first thing we have to do is get y by itself. Draw my river. Thing farthest away from y is negative 3x. So I'm going to undo that negative 3x by adding 3x to both sides. That cancels. We have 2y equals 3x plus 6. Divide everything by 2 and simplify. So y equals 3 halves x plus 3. Zoom out a little bit so that we can actually see that 3 there. Alright, so now we have a fraction in front of x, so we're going to use our multiples of the denominator. So I put my 0 in the middle. I'm looking at 2. So 2, 4, negative 2, negative 4. Let's start plugging in. 3 halves times negative 4 plus 3. 3 halves times negative 4 is negative 6. Plus 3 is negative 3. 3 halves times negative 2 is negative 3. Plus 3 is 0. And 3 halves times 0 plus 3. So we have 0 plus 3 equals 3. These are going up by 2's on the x side. We have plus 3, plus 3, plus 3, plus 3. And then we're ready to plot our points. So negative 4, negative 3, we go left 4, down 3. Negative 2, 0, we go left 2, up 0. 0, 3, we go left 0, up 3. 2, 6, we go right 2, up 6. And then 4, 9, we go right 4, up 9, a little off the graph. Now, when you go to connect these to form your line, let's say you made a mistake in your table, it's not going to form a line. If you end up making a design like this, and you have to do something crazy to connect your points, it means that something is not right in your table, so go back and check your work.